In our last lesson, we saw how to represent complex number in exponential form. In this lesson, we're going to take work examples on how to represent complex number in exponential form. We would convert from exponential form to rectangular form and also from rectangular form to exponential form. That said, let's get into class. Our first example says we should express minus 1 plus j in exponential form. Remember, in our last lesson we said that our exponential form will come in this form: z will be equals to r e raised to power j theta, where our r will come from the root of the square of the imaginary part, that's our b squared plus a squared, and our theta is the angle in radian. That's the angle in radian, which will come from theta, also will come from the tan inverse of the imaginary part, that's b, over the real part, a. Now our question says we should convert minus 1 plus j. This is the rectangular form, so my r here will be the same thing as the root of minus 1 all squared plus j. The coefficient of j here is 1. That will be the same thing as the root of minus 1 all squared is still 1, plus the root of 1 is 1. That means r now is the root of 2, which is the same thing as 1.414 from our calculator. Now the tan inverse, to find theta, our theta will come from the tan inverse of the imaginary part, which is 1, over here the real part also is 1. So that's the tan inverse of 1. Now the tan inverse of 1 from our basic trigonometry is 45 degrees. That's 45, but it doesn't stop there. Now let's go to our Cartesian geometry, because you see that my real part here is negative 1, that is, it's in the negative axis, and my imaginary part here is positive 1. So if I have both this way, that means I have my r coming in this way, so that here is where I have my 45 degrees. But this is the theta that I'm actually interested in, the anti-clockwise motion, which we explained in our last lesson. In case you missed our last lesson, please do not hesitate to check the description below. And for subsequent lessons on complex numbers, we have them in the description below. And here, my theta here will be equals to 180 degrees minus 45 degrees. So that my theta, the original theta here, is going to be 135 degrees. Now, one important thing that is worthy of note is that the angle we're interested in actually is theta, which is 135 degrees, but it's not meant to be in degrees, it's meant to be in radians. So we're going to convert to radians. So in converting to radians, I know that my 180 degrees is the same thing as pi radian. So that if my 180 degrees is pi radian, 135 degrees will be the same thing as pi times 135 over 180. Now 3 in 135, here is 4, here is 5, and 3 in 180, here is 6, and here is 0. Now 15 in 45 is 3, 15 in 60 is 4. So that's my 135 is the same thing as pi times 3 over 4 radian. Now that is the same thing as for my calculator. Let's use our calculator. Pi is 3.14 times 3 divided by 4. That's 2.355. That's 2.355 in radian. So that I can now place my z, my minus 1 plus j, which is my z, is the same thing as my r is 1.414, that's root 2. I can write it simply as root 2 e j 2.355, or I can also write it as 1.414, which is the value of the root 2, ej 2.355. Let's take my second example. Our second example wants us to now convert. In this case, we are converting from exponential form to rectangular form. Now, to convert from exponential form, here, this is e is raised to power 1 plus j pi over 2. Now, if you look at this closely, don't get confused with the 1 plus j is simple indices. Now, this is going to be, I can interpret this as 1e, that's e raised to power 1 times e raised to power j pi over 2. Now, so this now becomes e raised to power 1 times e raised to power j pi over 2. Now, compare this with, I want you to compare this with z is equals to r e raised to power j theta, where my r obviously here is e and my theta here is pi over 2. Now I can, if you remember that z also is the same thing as r, this is the same thing as r cos theta plus I sine theta. This will help me convert it fully to my rectangular form. Now, so that this is my r here now will become e into cos pi over 2 plus I sine pi over 2. Now, so that this is the same thing as e into, let me use this bracket, I'll have this is cos 90 plus I sine 90, bracket close. Now, so that this is the same thing as e now, cos 90 is 0, that will be e, okay, let me take it one after the other, this will be 0 plus, so in place of j I've been using I. Like I said in one of my videos, you can use them interchangeably. For complex numbers, some textbooks uses I, some use j. That should not be a thing of confusion. This will be I sine 90 is 1. That's 1. Bracket close. So that this is equals to e times 0 is 0. Then e now times I times 1 is e I. So in my complex form, or sorry, in my rectangular form, my final answer is e I. Thank you for staying with us. Also, in case you've not subscribed to our channel, please hit the subscribe button. That's a good way to encourage us and also to tell YouTube you love what we're doing, and YouTube will share our videos to other users. Thank you, and see you in our next class.